Now this is kind of interesting because you don't see a whole lot of like manipulating Gibbs free energy in problems. But in this problem, they give us that Gibbs free energy overall for this reaction right here is negative 34 kilojoules. And then they give us variations of this reaction above in 3 separate occasions. So all we have to really do is compare this equation to each one of these, and we can then manipulate our change in G. Now, just to be aware, if we manipulate things and if we reverse the change in G, then we're going to end up with a negative change in G. So if we reverse, a negative change in G. If we multiply by some integer, essentially what we're doing is we're going to multiply that by that same integer our change in G. Multiply, easy for me to write. So let's take a look at our actual problem here. And if we compare these first two right here, would you agree with me the only difference between this and this is that we have flipped the equation around, right? We've just flipped it. So if we flipped it, we're going to take this value right here and we're going to just flip it. So my value right here is going to end up being negative 34, sorry, it was negative 34 kilojoules. And what I'm going to do is get rid of that. And I don't know why it didn't erase. They've told me it will. They are lying. So that's going to be positive 34 kilojoules. So now let's look at the next one. If you compare the next one, we discover that two things have happened here. Not only have they reversed the equations, they reversed it, but haven't they also then multiplied it by 2? So we already know what the value is for the reversal because we just did it right here. Now we have the entire equation being multiplied by 2. So when we multiply this by 2, so over here we're going to end up with 68 kilojoules. And then finally, they go back to the original equation here. If you take a look, this is exactly the same as this, but they took this original equation, which had coefficients of 1, 3, and 2, and they multiplied them all by 3. So in that case, we're going to take this negative 34, and we're going to have to multiply that by 3. And when we do that, we end up with negative 102 kilojoules. Pretty straightforward. It's a little different than when we look at things farther ahead with equilibrium and how we manipulate equations. Here, it's kind of like Hess's law if you think about it. Hopefully this has been helpful.